Hi guys, I'm gonna go over assignment 8 and tutorial 8 in this video. Now in assignment 8, the first question, you have 90% confidence interval CI, and it's for a T distribution, so T interval. And once they calculated this confidence interval, they ended up with a lower and an upper point. The lower is 460, the upper is 500. I'm doing this for one of the versions. I don't know if you guys getting the same numbers. If not, it would be the different numbers, the same concept. And this was done on a sample of 25. First question is asking for what the sample mean is. Sample mean is x bar, so they're asking for x bar. If you have the lower and the upper point and you're trying to find the mean would be you add them, you add the lower to the upper, and you divide by 2. So be 460 plus 500 divide by 2, and that will give you the answer 480. So I'm gonna add this here, so my x bar is 480. Question 2, what's the value of the sample standard deviation? So they're looking for sample standard deviation, and that would be S. When you look at S, you can work with the upper point or the lower point. If you used to work with the upper point, figuring out S, the upper point would be x bar plus t star S over square root of n. If you choose to do the lower point, it would be the same formula but minus. And why I'm using t? Because they're telling me here that it's a t star distribution or a t star interval. I'm gonna erase some of this, and let me just find something to use here. So I'm gonna erase some of this to do the answer. So again, I'll choose the upper point. So I'm gonna choose this upper point. So it'll be 500. My x bar we just did, that's 480. I need my t star. To get this t star, you get it from the t table. To get this number from the t table, you need to know your df first. And df is degrees of freedom, and it's always n minus 1. So the entire sample, as we know, is 25. You minus 1, that's 24. And this confidence interval was at a 90%. So to get a t star, you get it from the t table. Degrees of freedom is n minus 1, 25 minus 1, because they tell you a sample is 25, and it's a 90%. Now, there is the t table, so I want you at this point to pause the video, see if you can go back to your Brightspace and the table section and open the t table. If you go to the t table, there's a column called df for degrees of freedom. You go down to the degree freedom 24, because that's what we have, In the bottom, you see percentages. You see something like 80%, 90%, 95%, that's at the bottom of the table, 98. And since you're 90%, you need the number that's common between degree freedom 24 and 90%. And the number that's common between them, it should be 1.711. So this number, 1711. So that's the number I'm going to use here, 1711. My S is what I'm trying to find, and it's the square root of n25. So I use this to find my sample standard deviation. So mathematically speaking, I bring the 480, so it'd be minus 480. I take 1711 over the square root of 25. That gives me a 3422S. This is 203422S, meaning 20 over 3422 would be your S. So I'm going to erase some of this here. So 20 over this will give you the standard deviation of 58.4454. That's your standard deviation. So now I'm going to add this to my information section, 58.4454. Now, going back to the question, they want you to do a 99% confidence interval to the same question. So they want you to find the lower and the upper. To do the confidence interval, this is number 3. It's x bar plus or minus t star s over square root of n. And when you add, that gives you the upper, and when you minus them, gives you the lower. Pretty much we have everything at this point, except they want you to do it at 99%. You get this from the table, T table of course. Degrees of freedom is still n minus 1, as 24. But now you're going to take the number with the degree freedom 94, 24, and 99%. So if you go to your T table, to find the number between degree freedom 24 and 99%, that's 2797. So this number here, 2797. So for x bar, I have 480. My T star is 2797. My standard deviation is the 58 and the square root of 25. Before I continue with the calculation, some technical terms I want to talk about because we will come across them later in the assignment. This portion of the confidence interval, S over square root of n, which is the 58 over the square root of 25, this is called SE, and that's standard error. Now the whole thing, the standard error times T star, what comes after the plus minus, this whole thing here is called ME, and that's margin of error. So it's recommended to do this in 2 steps. So you bring the first number down and then you do the margin of error. Just doing this part gives you 326943. Now you open brackets. Lower point you would minus them, so you go 480. Here where you minus. You go 480 minus 326943. Brings you down to 4473057. And here you add them. And when you add them, that takes you up to 5126943, and that would be your answer for the question. Now, one more after this. So this is the confidence interval when it's 99. And this is the confidence interval when it's 90%. They tell you this confidence, so in question 4, they give you a confidence interval. They tell you it's between 462.6 something and 497.38. And they ask you, they give you this and they ask you, this confidence interval was done on what percentage or what level? 90% was between 460-500, 99 between these two numbers. They give you this, can you figure out what this number is? Now the way we do this, you don't have to do the entire calculation again. But you see the first one, 90%? The length of this to go from this to this, we call this the width of the confidence interval. The width here is 40. That's the difference between the upper and the lower. When you increase the percentage, the width will be more. So anytime the width increases, that means the percentage increases. Here, if you take the difference between these two numbers, 497 minus 462, the difference is about 35, close to 35. So now the width decreases. When the width decreases, this also decreases. So I know that the answer must be less than 90%. Two of the answers are less than 90%, the 88 and the 85. 85 is the answer, so you have two tries. You try the 88 and then you try the 85 or vice versa, it doesn't matter. But I know the answer, probably for all the different versions, it would be 85%. Okay, so that's the first question. We'll go and do question number 2. So I'm going to erase this. Now when you read question number 2, they give you about 9 numbers. They all numbers representing apartments. And that's the rental rate and how much dollars per month. They give you all the different numbers. And they want you to construct the confidence interval again. And since this is a small sample, we're going to do the same confidence interval we did earlier. This is question 2, sorry. And you take the average plus or minus t star s square root of n. But if you notice, to be able to do this, I need to find the average, I need to find the standard deviation. Well, you know from the beginning of the course how to do the average. When you're given numbers, you would add them, divide by whatever. You know how to find the standard deviation. I'm not going to tell you how to do this. I'm assuming that you can. I did it earlier. Average is 545, and the standard deviation is 69.9553. So this I have, I know the sample is 9. Only thing left is to figure out what t star is. Again, we get the t star from the t table. We need degrees of freedom. It's always n minus 1. So this time it's 8, 9 minus 1, 8. And they want you to do it at 95%. So you go to the t table, you go to the degree freedom 8, and whatever comes with 95% would be your number. So I have the t table here. I go to degree freedom 8 and 95, 2.306. So I put everything together. Average is 545. My t star 2306. My standard deviation is a 69. And it's a sample of 9. I bring the first number down. I do the margin of error. Everything that comes after the plus minus is called margin of error. This part is standard error. So it's recommended that You bring the first number down, you only calculate the margin of error. This number is 537723, so now you can get the lower point by minusing them, upper point by adding them. You minus the 2, takes you down to 4912277. You add them, it takes you up to 5987723, and that's the answer. So we did the confidence interval. Then in question 2, they tell you wish to test a null hypothesis that the true mean for the unfurnished apartment is 500. What's the value of the test statistics? So when you do this hypothesis, the t statistics, we call it the t-stat for hypothesis. You'll see the formula in your formula sheet. It's basically x bar minus mu s square root of n. X bar is the 545, s is the 69, is the 9. Mu, what is mu? Mu is whatever they give you in the question. They tell you in the question that the rent is 500. So mu would be the number given in that section to 500. So you go 545 x bar, 500 mu, standard deviation 69, and square root of 9. So you do the calculation for this one. Answer would be 1.93, about 1.93. And then they tell you find the p-value, but for a different one. I'm gonna erase this, or some of it at least. Yeah, here. They tell you there was a test done on a sample of 16, provided a t-stat or a t-statistics of 271, and they want you to test this. What's the p-value? The question is p-value for this hypothesis. Rent not equal 500. When you get a hypothesis like this, rent or the mean does not equal a number. So in the null hypothesis, H0, we say it could equal, and here we say whatever the question is trying to prove. The question is trying to prove that it's not 500. That would be your alternative hypothesis versus your null hypothesis. So again, your null hypothesis is always equal, and since they talk about mean, so it would be mean equaling 500. HA would be whatever the question is trying to prove. And the question is trying to prove that mu is not 500. They tell you not equal 500. Now, HA is usually one of three things. In any hypothesis testing, H0 always equal. Whether it's mu or p or whatever, it's always equal. HA, you either gonna prove that you're more than something, you're less than something, or you're not equal. So that's always HA, is one of the three options. You could be proving that you're more or less or not equal. If you're more, it would be one tail. If you're less, it would be one tail. If you're not equal, that's the only time it's two tails. Okay, so we go back to the question. In the question, they tell you it's a sample of 16. T-stat is 2.71. What's the p-value? p-value for t, we need to do what's called the DTT. Degrees of freedom, test, tail. We'll start with the degree of freedom. It's always n minus 1, so it's 16 minus 1, 15. Test is 271. Tail, 2, because it's not equal. So anytime you do a p-value for t, you need to figure out your DTT, degrees of freedom, test, and tail. Now go to your t-table, go to the degree freedom 24, go down to the degree freedom 24, and in this line, look for the number 271. What is it between? You should see that 271 in line 24 is somewhere between 2.49 and, let me see, and 2797. So your number is between these two. So you put your two fingers, you go up to the two-tailed percentage. So if you go up to the two-tailed percentage, you'll see that it's between, p-value is between the two numbers, 2% and 1%. Because these two numbers, if you go up to the two-tail, because we have a two-tail system, it would be between 1% and 2%, and that would be your answer. Okay, so we go back to kappa. So your answer would be between 1% and 2%. And go to the next one. Question 3. Question 3, they give you 14 numbers, and they all independent measurements. Okay, and they ask what's the standard error for the system, and find the 95%. So it's a confidence interval question, and it told you it's x bar t s square root of n. And since they gave you the numbers, you need the x bar s, you know how to do them. There are the formulas we talked about since the beginning of the semester. Average, you add them, divide, and whatever. I did this earlier. Average is 15, 7, 8, 5, 7, and the standard deviation is 4, 5, 2, 6, 5. Now, the first question is asking for the standard error only this part. So you only take the s, that's your standard. You take the s, and you divide it by the square root of 14. So when you take this 4, 5, 2, 6, 5 over the square root of 14, it gives you 12098. And then they tell you find a 95 confidence interval. So now they want you to do the entire confidence interval. We did this earlier. To get this, we need degrees of freedom, n minus 1. And it's at the level 95. So I go to the t-table, go down to the degree freedom 13, and 95, 2.16. So the number is 2.16, that's your t-star. So you go average, t-star, times standard error, which is the 12098, 15, 7, 8, 5, 7. You multiply 16. And I told you, here you minus them, here you add them, and you get the answer. You know how to do it. Okay, for this question, this assignment, there is one more question, and that's question 4. Okay. A school board is evaluating a learning system designed to increase literacy skills, standardized tests measuring them both before and after. So they want to test how people are doing after a certain learning system. So they tested them before and after. Anytime you see this before, after, then you know that it's a dependent system, also called paired system. And if you look at the question in your assignment, you'll have something like student and 1, 2, 3, 4 all the way to 9. And then you have the before and the after numbers. And you have a line called D. And D is difference. And they tell you it's after minus before. So this number minus this number is 0. And then 4, 4 minus 1, 5, 6. Sorry, minus 6, 4, 5. 6, 4, 5. And 1, 1. Oh, last one is negative 1 actually. And then they ask you all kinds of questions. So I'll come back to this later. Now, they tell you what's the null hypothesis, what's the alternative. So what is H0, what is HA? Since this is a dependent system, we use this simple, mu of D. This one is always equal 0. Because I said earlier, H0 is always equal, and in this case it's 0 always. And if you read the question, right after the table, they tell you want to answer this question. Is there any evidence that there is increasing? There is an increased number or whatever. Testing for increase, then you say more than 0. If it says less, decrease, less than 0, if you're testing for not equal, it would be not equal. Increase, as we said earlier, it would make it a one-tail system. So this is H0, this is HA. Then, and this is question 1, actually question 2. Question 3 is asking for degrees of freedom. That's n minus 1, 9 minus 1, 8. And what's the sample standard deviation for difference? So they want you to find the sample standard deviation. Okay, to do this, you go back here and you add something called d squared. You square each number. 0 squared is 0, 4 squared is 16, this one is 16, negative 1 squared is 1, 36, 4 squared, 5 squared, 1 squared, 1 squared. Now, you find the sum of all of these. So you add them all up. So 0 plus 4 plus 4 minus 1 plus 6 plus 4 plus 5 plus 1 minus 1. That gives you 22. You also add up everything in this line. 16 plus 16 plus 1, 13, 36, 16, 25, and 1 and 1, 112. They want you to find the standard deviation. Standard deviation in this case, you put everything in this formula. The sum of d squared minus the sum of d entirely squared over n all over n minus 1. So 112, 22 for the sum of d. You square this. There are 9 numbers, and here 9 minus 1. So I do the calculation for this question. The answer is 2.6977. And if you round it up to 2 decimal places, it would be 2.70. And then they ask you for what's the t-statistic for this question. Now t-statistics for this type of question, I'm going to erase some of this. Or you know what, I'll do it here. Now for the t statistics, we follow this formula. D bar minus mu d SD square root of m. Now d bar would be the average of all the differences. So you take the sum of differences, you divide by n. So you take the 22, you divide by 9, because the sum of differences is 22. That gives you 2.4444. Now I put everything in the formula. My d bar is 2444. Mu d, I told you earlier, is 0. The standard deviation is the 27 we found. And it's the square root of sample 9. So you do this in the calculator, and that gives you about 2.716. And that would be your answer, 2.716. The last question, two more questions. What's the p-value? Okay, I'm gonna erase from here. We did the p-value question in the previous one. P-value t, you need to do the DTT. Degrees of freedom, test, tail. We know degree of freedom was n minus 1, 9 minus 1, 8. We just found this to be 2716. And tail is 1 because you're testing for increase. You go to the t-table. You go to the degree of freedom 8. You look for the 27. You'll see the 27 is between 2328. You put your two fingers on the 2328, you go up to the one tail. P-value would be between 1% and 2.5%. Again, you go to the degree freedom 8, you look in this line, degree freedom 8 for this number 2.7. You'll see that it's in line 8, it's between 2.3 and 2.8. So somewhere between them, you put your two fingers, you go up to the one tail, because it's a one tail system, it's between 1 and 2.5%. Now, for the last one, is there any evidence of increase using alpha 5%? So, they give you alpha of 5%. So they tell you your alpha is 5%. Now this is the rule we go by in rejecting or whatever. So if you found p-value to be less than alpha, you're going to reject H0 and conclude HA. If you found p-value to be more than alpha, you're not rejecting H0, you're not concluding HA. In your case, p-value between 1 and 2.5, say 2%. 2% is less than alpha. So 2% is less than alpha. We know that this is the answer. We know that we're rejecting H0 and we're concluding HA. And the HA says increase, so we're concluding that there is increase. So the answer would be, is there evidence of increase? You say yes, because you're rejecting H0, concluding HA, and HA is increase. Yes, there is increase. Okay, this is the video for part 1. That's for the tutorial. I'm gonna stop. I'm gonna record another video for, sorry, this is for the assignment. Now I'm gonna record another video for the tutorial.